Right, so this is the topic on mensuration. Definitely area, volume, and in particular surface area. I think in maths, just like any other topic, you realize I need to form a relationship or use a relationship to form the equation. So they have two distinct things. They're comparing total surface area of this solid here versus another thing that is not drawn there. Okay? Cone. So you need to be clear how do you write the total surface area of a cone? What's the formula for it? No, it's just pi RL for surface area of the cone around it. So if this is the cone, it's just the outside. Okay? But this is only the surrounding area. The bottom actually has a circle, so plus pi r squared. We assume it's a solid cone. Okay with that? So we're comparing this solid area over to this solid, and this one is twice of that one. So I can start to form my equation where I know that the solid in the picture right now is bigger than the other one, right? So to make them equal, I must multiply to the smaller one, which is the cone. So surface area of the cone, which is pi RL and pi r squared. Okay, then now I'm going to write in red the equivalent of all the surface area of the two hemispheres joined together, which will end up with one full sphere, and the surface area of the cylinder. Okay, so surface area of the sphere is quite okay. It's given in the front page. If I'm not wrong, it's just 4 pi r squared, right? Okay, now the challenging one, which a lot of people have not noticed it since lower sec mensuration, is that this area here, or this surface area going around this, is actually a rectangle. Exactly. So in that rectangle, where should I draw it? In that rectangle, this area here in red is actually the circumference of the hemisphere or the circle. It opens up. So this will be your length times your breadth, right? So then now I'm just writing out plus length times breadth. So the length would be 2 pi r because it's the circumference of the circle. So length times the breadth of 2r. Okay? So at this point of time, so now we just have to sort of simplify this. So if you look carefully now, I'm going to use everything in black. Just multiply it out. This one will be 4 pi r squared, right? 4 pi r squared. Okay with that? Exactly the same. Okay, equals to 2 pi rl plus 2 pi r squared. Now a common trick in many mensuration questions is that actually there are some terms that are in common throughout all terms. For example, the pi. Can you see that? So I can just divide them away. I cancel them away. People like to say cancel. So cancel, 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 cancel. Because I can divide by pi throughout and everything just disappears nicely. Okay? Next, other things in common is actually the r. But the only thing that's in common is just r, not r squared. So I will just divide by r and I will start cancelling certain things away. R squared become r squared become r, totally no r, and then r squared. On top of that, can you see there's a lot of 4s and 2s here? I'll just divide. Okay, so what will I be left with? By 2, 2r plus 2r again. By 2 left l, left r. Okay, so therefore now moving on, L in terms of r is like subject of formula, so your target is here. I just bring this one over here, so it's just 4r minus r. And therefore last part, L is just left with 3r.